Yesterday, just 43 million kilometres away, Venus was sliding between us and the Sun. But here at Sydney Observatory, so were plenty of clouds.
What are your chances of seeing the transit today, do you reckon?
I don't think we'll see it.
Next to nothing.
I don't expect to see very much at all, to be honest.
They're waiting for that blue patch over there and we're going to run.
Just after the transit of Venus starts, the clouds part and people get their first look.
Oh, wow. Oh, wow.
Okay, so right on the spot.
Yeah.
You're within the sun.
Got it.
So you're doing...
I can see it.
Oh, yeah, okay.
Wow. That's really cool.
That is amazing. I can see Venus just like a pea on the edge of the huge golden orb. It's quite remarkable to be able to see a planet, a whole planet, silhouetted against the nearest star.
In the past, timing the transit from different viewpoints was the key to measuring the universe.
Everybody knew the ratio of the planets from the Sun, but they didn't know the exact distance to any of them. So this was kind of like unlocking the size of the solar system with the biggest ruler.
These days, scientists study the transit for very different reasons, as GRAHAM PHILLIPS finds out at Macquarie University.
Back in Cook's day, the purpose of observing the transit was to try to work out how far the Earth is from the Sun. Now, we can do that with a radar these days. This time round, astronomers are trying to learn about other star systems. Specifically, about the planets orbiting distant suns. They're called exoplanets. Carlos's day job is exoplanet hunting. For the search, he's building a new highly sensitive instrument. It'll analyse a star's light spectrum in incredible detail, allowing tiny wobbles in the star to be detected.
We have the star and we have the planet going around the star. Now, we all know that the star is holding the planet in place, but sometimes it's hard to think that the planet is also moving the star.
The planet's gravity tugs on the star, forcing the star into that tiny inner orbit.
We have to be very precise, and if we are, we can actually see that movement, and then if we analyze it properly, we can see the planet.
But there's another way of detecting exoplanets. Watching while they transit their suns, just like a Venus transit. Rather than measuring a wobble, blocked starlight is detected.
We can look at the luminosity of the main star, and when we see that it decreases, and that happens periodically, that could be a signature of a planet around that star. It's a very useful method because it can give us a lot more information than just the presence of a planet.
The size of a planet can be worked out from the amount of light that's blocked. The reason astronomers are so excited about the transit of Venus is they get to see a transit up close.
We know information on the Sun very well. We know information on Venus very well, so we can make calculations of what it would look like to see the Sun through Venus.
That information can be applied to suns and exoplanets we don't know so well, leading to new discoveries. One telescope that will be keenly watching the transit is Hubble. It's made so many amazing discoveries over its decades in space. But its highly sensitive instruments would burn out if pointed directly at the Sun.
The Hubble Space Telescope is going to be looking at the Moon, and it's going to look at the sunlight reflected on the Moon while the planet Venus is going in front of it.
That reflected light will have passed through Venus's atmosphere, and so will carry telltale signs of the gases encountered on the way. Astronomers can work out the makeup of Venus's skies just from the moonshine. And that's exciting because the same technique could be used to find out about exoplanet skies.
Back at Sydney Observatory, you don't need a modern telescope to view the Sun.
This beautiful old instrument is the Russell Telescope. It's the oldest working telescope in Australia. It's been here since 1874. And today, it becomes one of the few in the world to have observed 3 transits of Venus.
Typically, you find such a magnificent instrument unusable. It's usually just an exhibit, but we have it here in use today. So we're actually doing some cultural astronomy.
The transit inspires people of all ages to pause, and wonder about our place in the solar system.
It's amazing to look up at that black spot and think that's a whole planet I'm looking at.
That's the size of the Earth and just how tiny, 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 tiny we are compared to the Sun.
Thanks very much to those who sent us your photos. Here are some of the best.
And that's it for this transit. You won't see Venus quite like this for another century or so. And we're taking a break at Catalyst 2, just for a few weeks. We'll be back in August. In the meantime, check out our website and stay in touch with us on Facebook. See you soon.